My name's Dave White. Just been around for a long time. I'm actually the program director for the KCP program. So if you guys have any questions about KCP stuff, I'm the guy to come in and talk to. And I'd love to talk to you about it. I want more KCPs. Anyways, we're just going to do this sort of, got a little bit of Kanban system here. We're going to do these in an order that I just randomly picked, except Daniel gets to go first because his machine's set up. So this is lightning talks. The format is 5 minutes-ish. We'll let people go a little bit over. And we're going to try and just keep them going. There's no questions, so we're just going to lightning talk, then we'll quickly transition to the next person. So without further ado, Daniel, it's up to you.
My name is Daniel Doiron. I'm from Montreal. I'm glad to be here in Miami. And the title is a bit catchy. It's called The Law of 50. And today I want to talk to you about risk and the way that we usually go about reducing risk is to, of course, gathering additional information. And oddly enough, as human, we learn through our failures. We don't necessarily learn through successes. To appreciate the value of information and reducing risk, we must understand that a man recognizes failure 28 seconds faster than success. So we do learn through our failures. So the lesson to be learned here is that whenever we go about in a project to do a proof of concept, validate our assumptions, obtaining feedback, and reducing risk, we have to take this law of 50 into account. And what is the law of 50? If you see on the graph, it basically says that when your probability of failure is around 50%, this is where you get the most information. And there are examples of that in the real world. For example, in drug testing, to ascertain the toxicity of a drug, the pharmaceutical industry aims for a survival rate of 50% in the animals that they test. This is the way that they get the maximum amount of information. Also, when an operating system does a search for a file, it does what we all know to be a binary search. It doesn't go sequentially, doesn't go randomly. It hits straight down the binary tree and reduces the chance of failure by 50% every time. Also in engineering, if you have, for example, a pipeline from A to B and there's no feedback, an engineer would usually start in the middle and decide from that point on to go either upstream or downstream. In real life, if a new wine comes up, you wouldn't go and buy a 6-pack or a case of 12. You would usually buy a single bottle, taste it, get information, reduce your risk, and act accordingly. Now, there's something interesting about the curve. And usually, when we go on our day-to-day business, delivering value, we deal mostly with efficiency. You know, we're concerned with input, output, and maximizing this. But when we design those proof of concept, those prototypes, those tests to reduce our assumptions, we're basically dealing with effectiveness. And we enter a whole new world that is quite the opposite of efficiency, and that we enter the world of probability. On your first prototype, if you design it properly, you'll get information, and you may want to go about and do another version of that prototype. And then you enter the world of conditional probabilities, Bayes' theorem, and things that we don't usually do in our day-to-day job, being concerned on efficiency. So what's valuable information? If you undertake an experiment and succeed, knowing beforehand that your chance of success was 90%, you have learned very little. Likewise, if you build a prototype expecting to fail and do so, you have not learned anything at all. If you succeed when you were sure to fail, you have gained valuable information, and conversely, if you fail when you were certain to succeed, you have gained again valuable information. The point of all this is not to go about and undertake trivial experiment that will just increase your WIP. Too many times we go into proof of concept, validating assumptions, knowing pretty well that we're going to be successful. This should be avoided, should be designed properly, and maybe sometimes we should opt out of such trivial tests. So, what's valuable information again? Unexpected success, unexpected failure, and yes, we can design it. Of course, when we are running software and testing software, we gotta aim for 100% success rate. But here I'm talking about proof of concept, prototype, that are often needed in the day-to-day progression of a project. So, to conclude, the law of 50, of course, is something that I've labeled. There's the law of 15 and the law of 150 in Agile. Now there's the law of 50. But I was mostly inspired by the work of Donald through 2 of his latest books, and also an article on the web, which is the 4 imposters: success, failure, knowledge, creation, and learning. That's it. Thank you.
Okay, so my name is Patrick Steyaert, and so I want to reach out and get a certain conversation going. So in terms of reaching out, I was at the Entrepreneurship Conference in London a couple of weeks back, where people from large organizations come together to share experiences and learn about how to stimulate entrepreneurship, innovation in their organizations. So surely it's no surprise, it's clearly evident that the biggest challenge that organizations, especially large organizations, are facing today is innovation and change. So not only in terms of changing from their analog present to a digital future, but also in terms of making the paradigm shift from mainly execution thinking to a mindset of innovation. The thinking at the conference is like, and I think in many places is organizations that are not able to make that transition run the danger of becoming irrelevant in the marketplace. So I don't think that's anything new. Knowledge work plays a critical role in that transition. So not only in terms of exploiting existing knowledge in solving non-routine problems, but more importantly in terms of exploring new knowledge in order to find the relevant problems that need to be solved. And again, the keyword is relevant here. Organizations develop blinders that prevent them to spot the invisible gorillas that are hiding in plain sight. Typical invisible gorillas would be just startups that are threatening to eat the lunch of these large organizations. And these same blinders also prevent these organizations to nurture the ugly ducklings that at the time when they need nurturing the most. So in other words, they have a hard time, because of these blinders, they have a hard time in spotting and taking serious changes in the marketplace that threaten the relevance of the organization. And at the same time, they have a hard time in nurturing ideas into initiatives that ensure their future relevance. So, what is the relevance of Kanban in all of this? The focus of Kanban on managing knowledge work, makes it clearly very relevant in this context. But at the same time, I do think we also need to examine our own biases and blinders and work on that. So one of the biases I think we need to examine is our bias on work, on managing work. Surely we design and model our Kanban systems around a knowledge discovery process. But in the context of innovation and change, I think we need to go a step further than that. So we not only need to manage the flow of work in that knowledge discovery process, but we also need to manage the flow of knowledge. Okay, where does the knowledge come from? How does knowledge flow across teams? How do teams share knowledge? Where does the knowledge go to? How do we manage knowledge bottlenecks? So that's one part of it. The other part I think is important is managing uncertainty. And again, managing uncertainty is a critical element of Kanban. But in this case, we're not talking about managing the uncertainty of delivery, managing delivery uncertainty, but we're actually talking about managing discovery uncertainty. So discovery uncertainty in terms of finding out the relevant problems to be solved. In the context of sustaining innovation, this can be the uncertainty around desirability. In terms of disruptive innovation, this can be uncertainty around viability, around feasibility, around effectiveness, if we're talking about process innovation. Now, Kanban systems, managing the uncertainty is always about observing, making sense, experimentation, creating options, and we do have Kanban systems that actually manage that uncertainty by visualizing the uncertainty in the feedback loops that we're using to manage that uncertainty. But we need to start creating a framework around that. So I want to reach out, and so many people in the room have experience in terms of using Kanban systems in the context of innovation. I think it's important to reach out to that context of innovation, to share those experiences, and then create a framework around that. For that purpose, we started developing this poster. The poster can be found in the coffee break area. Just grab me. I'm very eager to share experiences and start a conversation around that. Thank you.
My name is Rodrigo. I'm from Knowledge 21 in Brazil, and I'm here to talk a little bit about a pull system for education. So what we are proposing is, instead of doing the traditional pull system, when you give the student the content and you hope that maybe they use this content a few years later, instead of it, we are proposing a pull system when we give just-in-time information for the students. As they need, we give the content. Okay. So I'm also a professor in the Federal University of Rio, so I'm using this in the last few years. Actually, we see this like in three different levels: in a micro level, in the intermediate level, and also in the macro level. For this micro level, we use Coding Dojo. In the middle level, we use the practice before theory, and for the macro level, I have done a completely curriculum inversion. Okay, so I'll explain the three levels here. So Coding Dojo, maybe some of you already know it. We give a challenge to the students, like 1 hour and a half they can achieve the challenge. Then we ask for 2 of them come in the front. They do like a pair programming. We give a baby step challenge, so they have 5 minutes to achieve. Either they achieve it or the 5 minutes are finished. Then we open to questions. So we give just-in-time information as they need So if they have any question, we answer, or if someone on the audience didn't get what they have done, then we explain. Each 5 minutes we do just-in-time information, okay? So it's in the micro level, each 5 minutes. We have written a paper, an academic paper about it. It's in Portuguese, but you can find it, and maybe the Google can translate for you. But we have mapped this dojo cycle, and we noticed that there are 2 pull systems happening in this cycle, okay? So this is in the micro level. In the middle level, we have done the practice before theory. Instead of giving a class of theory and then give the class a practical class, like in the lab, typically in a lab for computer science, we are doing not in the traditional way. The traditional way is that it's like this: theory first, then people will stay like this. Okay. And then practice later. Okay, now I got it, now I understood. So let's do the inversion. Let's do first practice and then theory. So I have an example for you here of this inversion. I teach also computer graphics. I teach both agile methods and computer graphics in the university. So unfortunately, I think the image is not so good there, but it's the Bezier curve. So we do a dojo with several baby steps. So for example, the first baby step is draw a line, okay? Then draw 2 lines and interpolate them so it becomes a parabol, okay? And then we draw the next baby step, draw 3 lines, 2 parabols, and then interpolate the parabols, and then finally they have the Bezier curve. It's a 3rd degree curve. Then they understand it. Okay, that's a 3rd degree because it's the interpolation of the interpolation of the interpolation. Okay, next class, we'll give the theory. And then in theory, we can go further in the explanation. We can explain higher order curves. We can explain Bezier surface, how to convert from one type of surface to the other type of surface. They know it because they have already done the basic stuff in the practical class. And finally, the complete curriculum inversion is, again, a computer graphics example. Usually, we teach at the beginning the basic stuff, like how to draw a triangle, and then what is a geometric representation, and then object visualization, and then detailed visualization. At the end of the semester, they could produce a game with all this content. Now, we do on the opposite way. First week, let's do a game. And then after doing the game, they are, okay, there are some visual effects. Why they work or how they work. Then we started explaining that. So instead of starting with the basic stuff, we start with the result. And then as they get interested in the content, then we explain the basic algorithms and everything else. So sometimes it doesn't go, it's hard to have 2 semesters with the same order because it depends on their curiosity, okay? So it's a little bit more work for the professor, but they are interested all the time. And then understand why. So the results are this: more focus on why instead of how, higher audience interest, especially on theory classes. It's applicable on trainings. We have been doing this for teaching Scrum, Kanban, and everything. It works for undergraduate courses, also for graduate courses. And these are a list of other stuff that we take from Agile and we apply them on our classes. If you want to, each bullet here could be a lightning talk. So if you want to ask something about it, I can explain you later. And that's it. How many time? It was okay? 5 minutes? Thank you.
So, so I have this theory that a lot of managers don't really understand test-driven development very well. And it's not so much a theory as it is the truth, because I go around trying to teach folks test-driven development, and you get a lot of resistance, not only from developers when they're first learning it, but from managers, and it's hard to explain it in a way that makes sense. It's hard to explain it to developers and really hard to explain it to managers. So I thought I'd give a shot at explaining test-driven development kind of with a lean bent to it. So maybe managers who have some experience with lean thinking can appreciate it a little bit more. My first slide is missing, or it's not missing, but it's anyway. So this might be a first for LKNA, but you're going to get to watch me code, although it'll be 4 times as fast as normal. So you don't get to see me make all the mistakes. All right. So without further ado, here is coding without test-driven development and what it looks like. All right. So I don't know how it's going to show up on here, but in any case, this is a Roman numerals kata, and basically we're creating a class here to take an Arabic numeral and convert it into a Roman numeral. The first thing I noticed when I started doing this was, without test-driven development, is it was hard to figure out how to start. You can see anytime the cursor is just sitting there blinking for a while, that's me sitting and wondering what I should do next, and trying to keep everything in my head and figure out what steps I should take. And it's hard. So you can see, well, you may or may not be able to tell, but I've already taken on 3 cases. I'm trying to solve the case for 1, 2, and 3 at the same time. And I'm not getting any feedback. I'm just writing code, just writing a bunch of code. And so my whip at this point is 3, right? So I'm working on 3 different cases at the same time. I'm now moving on to the 5th case. So I did 1, 2, and 3 in the code, and now I'm working on 5. I don't know whether any of this works, so I started writing these little output statements. So now the log will pop up and show me what it actually did, and we see that everything's returning a 1 or an I. So clearly that's not right. My test was wrong up at the top. So I found that as I was doing this again, I haven't written code without test-driven development in a long time, and I found myself kind of falling back into trying to fake test-driven development as I was doing it by using these logging statements up at the top. And there's really it was really frustrating to work like this because there's no real, there's no flow, there's no, you have to keep a lot of stuff in your head, and a lot of multitasking, a lot of context switching, and the lack of a real short feedback loop was really painful. So here you can see that I've gotten 1, 2, 3, 4, and 5 working, and then I'm moving on to 6. So here comes 6, and the other thing to notice is that there's no real, it felt very frantic while I was working on it as well, so there was no real opportunity to do any refactoring. And so there was a lot of, the code is just kind of looking kind of ridiculous at this point. So any coders in the room would, it's just like a bunch of if statements, and it's like really dumb. There's no abstractions being generated. It's just very poor from a code maintenance perspective and so on. So we end up with this solution. And this is not really a contrived example. I actually did this with intent of trying to do a really good job. So, and so here I've done 1 through 6, 9, and 10. I don't know what happened to 7 and 8. I intended to do them, but I didn't do them apparently. So I just skipped over in 7 and 8. So who knows if those even work. All right, so let's see what it looks like with test-driven development. So this is on the plane on the way here, so it was late too. All right. So the first thing we do is we create a test. Now this test-driven development cycle is red, green, refactor, and there's another little step that we'll add in here as well. So you'll see up in the top it says red, green, refactor. It tells you what kind of step we're on right now. So right now we're writing a failing test to prove that we have we don't have code. And then the next step is going to be write the code to get that test to pass. So this is the green stage where we're trying to write the actual production code, the simplest code possible to get it to pass. That little bar up in the side will show a passing test. I've added a step called commit. So now we have red, green, refactor, commit. With modern development tooling, that's really a great way to work. So you just write a failing test, passing test, commit, and move on. Here we're doing, we did 1 and 2, and you can see the implementation of 1 and 2 are actually very stupid. They're returning 1 and 2. But what we do now is once we do that stupid implementation, then we detect patterns and we start to refactor them into abstractions. Okay, and we can do that because there's less thinking involved. Right now, there's a test for 1, there's a test for 2, and a test for 3. I'm doing them one at a time, so your work in progress is always staying at 1. Okay, and this is a refactor step. We're actually refactoring the tests at this point to make them a little more simple. Go back into the commit cycle, and here comes number 4. And we've got another failing test you can see. So you kind of can see this little pattern developing: red, green, refactor, commit, red, green, refactor, commit. In this particular example, because it's so simple, there's not that many refactorings, so sometimes that step gets skipped. So you can see now that this, I'm starting to put in number 5 right now, and that one goes in fairly easily. And again, you don't have to think now about all these other ones that have passed. You don't have, in the previous example, I had to keep scanning that entire list of output to see if there were any problems or errors. In this case, I don't have to do anything. As long as I get a green bar up there, I know all of those previous tests have passed. So it's really fast and quick feedback. All right. So I also detected as I was doing this that there was an opportunity to do some recursion, and I didn't even notice that the first time I did this. Surprisingly, I haven't done this Roman numeral kata before, but I didn't notice that there was a recursion opportunity, and so when I was doing it this way, I had time to think, and it gave me, it kind of opened up my eyes to, oh, well, this would be, now it's possible that it was the second time I did it, so maybe I saw it because of that, but I don't think that actually was the case. I just felt, even though I was making up my own time pressure, I felt less pressured doing it this way. All right, so I started seeing some abstractions here and some commonality. There's, it's arguably still not great code, but there's now a converter. It keeps going back in a loop, and you can detect more patterns. It's fairly easy to look at that code and see that there's some commonality that could probably be extracted further. And so this is well, it's gone now. But that was the final little bit of it, and so you end up getting flow through your system, and low work in progress is really the main lean principle that we have when we're doing test-driven development. So that's it.
Hi, I'm Nate Conroy. I am a transformation coach. I work for the U.S. Citizenship and Immigration Service. We're using Kanban to improve the services we provide to folks who are applying for immigration benefits in the U.S. One of the things I do is train folks on introductory classes, and we were just having a good conversation with our lunch companions about how do you get people over this initial hump of accessing Kanban and relating to it. We found that personal Kanban really helps in these intro classes. We got to get people over that J curve of working this way. But today, I actually just wanted to talk about a personal issue, which is using visual systems in parenting. The power of visualization, starting where you are. How many people in here are parents? So I have an 11-year-old son. Okay, how many of you have encountered resistance? All the same hands. How many people of you have repeated yourself a few times when you're talking to your parents, right? Talking to your children and your parents, right? This makes your relationships difficult. You may start to take it personally. It can really, start to have an impact over time when you feel like you're repeating yourself, and why won't they do what I'm asking them to do? So my son and I were kind of at a very frustrated point in this February, and we had used 2 previous point systems, actually, kind of major revisions tracking things that he needs to work on. And similar to story points, if you've used those, they can be a bit abstract and difficult. So I really wanted to draw a direct relationship between privileges and responsibilities, which as a parent, that's one of the main things that it's your job to teach your kid. If you don't work, you don't eat, that kind of thing. So I took a bunch of blue cards, and I just started writing all the things I wanted him to do, some things that came easy to him, and some things that I felt like I was just repeating over and over again. He took some green cards and wrote out all the privileges that he would like to have, and some examples that I wrote were good mornings, right? If we start the day right, both of our days are going to go a lot better. If we're not in conflict in the morning, going to his math teacher a couple extra times during lunch. He wrote things like going to the movies with his friends. So the first revelation that I had was neither of our lists was that long, right? We could get our arms around this, and it didn't need to be a constant nagging type of situation. Actually, it was a pretty short list of things that I was asking him to do. The second thing is that some natural categories emerged once I saw all the cards out on the table. The categories are in school, out of school, school organization, chores, and hygiene, and being a good person. So we started having a weekly meeting, and if the meeting went well and it showed improvement, then he would take a privilege and move it over into the privilege earn category. And that started happening very quickly. And we visualized all of the responsibilities. The columns there are needs work, improving, and good. And over time, we saw things start to move to the right. This helped enable him to make adjustments. It helped him choose focus areas, right? He was limiting the amount of things he was working on based on what we had seen that actually needed improvement that particular week. And he was able to catch things before they got too bad, right? Because we were meeting every week. You know, we got into a rhythm of we'd go to his soccer game and then he'd have some time to work on things. He learned to do tests, right? Test his own cards. So start to learn to parent himself and say, okay, if when we meet I want to have a clean backpack, then I probably should check the backpack before this 2 p.m. meeting that we started having. So that really accomplished a lot. And one thing that I thought was actually quite profound was that the privilege cards, some of the ones he wrote actually seemed to form a nice flow of life privileges. So he wrote earn responsibility, make you proud, get good grades, celebrating going to 7th grade, get into college to become a scientist, and then able to do everything without being told, right? When you're at that age where you're in middle school, children start to separate away from their parents, and you know, we all want autonomy, right? And so to hear that in a child's language really was interesting to me. And you know, if you work and you make progress in life, you actually do earn the privilege to do what you want. So I hope that this talk is permission giving for all of you to use these things that we learn and that we love using with Kanban with all of our customers, and use them in all spheres of your lives. And you know, hopefully we can improve people's lives with these things, starting with ourselves. Thanks.
Fit for purpose. Yeah, what do you think about this slide? I don't even know that I have to prepare a slide for the lightning talk. I came to know that I have prepared the slide later in the morning, so I just prepared the slide. It's totally fit for purpose. And another thing about this picture, fit for purpose, is morning, many of you guys asked me where I got this dress or t-shirt, whatever it is. It's an Excel t-shirt. David Anderson gave it to me in one of the conference. I just altered it for this event, so I thought like, this will be the real fit for purpose. So this fit for my purpose. So that's the interesting thing about this slide. I seriously didn't want to talk about Kanban, technical, whatever it is. I just wanted to share a story which enlightened me that, oh my God, that's fit for purpose. So I'm just going to talk about a little story. Once there was a monk who was meditating with his disciples, and daily in the morning, 9 o'clock, there used to be a cat making noise, disturbing everybody doing the meditation. So the monk tried to calm the cat, but cat kept on making noise. It was going crazy. So daily, before going for the meditation, he asks one of the disciples to tie the cat and then start the meditation. So what happens is, after a while, the monk died, but the cat was living. So what happened was another monk took over as a priest, and then Shifu, what he did is, he said like, okay, tie the cat and then do the meditation. It went on for a while, and then the cat died. So when the cat died, guess what happened? So the next monk asked for one of the disciples to go buy a cat, bring it out, tie it, and then start the meditation. So the other disciple, he went on for buying the cat and for tying it so that they can start the meditation. So they really don't know why they created the process of tying the cat. It's because it's making noise for doing the meditation. They wanted to tie the cat. But whoever is coming after, they really don't know why they created the process, why they did whatever they were doing. So this is one of the things I face in many of the organizations when I do Kanban coaching, wherever I go. It's like, okay, can we do it this way? Why are you guys doing this way? Like, I don't know, it's a process, we have to do it, something like that. This is what is happening in many of the organizations. Right now I'm working with Cisco, and like Especially, I was thinking that it's a bigger organization do that. Even smaller organizations do that. I worked for some couple of startups. I did it. I enforced the same in American Express, Kaiser, Cisco, everywhere it happens. So I start with this story and said, like, dudes, we have to see what we wanted to do. Let's do what is needed for doing, not just because of the heck of a process we have to do it. So I just wanted to share this story. So that's all I have to say. Thank you, guys.
Hi, my name is Craig Strong, and today I'll be talking about improving a Scrum implementation via the Kanban method. So I work on a criminal justice project as a technical lead for a federal government agency. Unfortunately, I can't tell you the name of the agency nor the name of the project, but in the overall cycle of this criminal justice, that's us in the lower right-hand corner. So why do we pick Scrum? Well, at the time, we knew we wanted to transform the project from waterfall to agile, and there had been some high-profile success stories with Scrum, as well as some recent changes in the federal acquisition regulations. So we felt we had permission to try Scrum. So our task was to transform the project from waterfall with long release cycles and stage gates, phase gates, to Scrum. So we picked a fairly straightforward Scrum implementation, 6-month release cycles, 4-week sprints. Then we decided, okay, we're going to quantify everything we do. So we came up with a taxonomy of user stories and tasks. And our main concern was to understand the difference between the business user stories, the features, and the technical, we called technical or infrastructure stories, because we knew we had a lot of technical debt, being a legacy project, and a lot of automated tests that we needed to build. So that was our initial set of work item types. Okay, so we entered our user stories, we entered our tasks into our Scrum tool, and away we went. And every morning we sat around and we all answered the 3 questions. So everything was fine, right? Well, unfortunately not. So we found we had 3 problems. So the first one was we kept missing our sprint commitments. And everyone was getting very stressed. And we found that everyone was working on a lot of different tasks simultaneously and constantly getting interrupted. Another issue we ran into was it being the federal government, we had a lot of documentation to do. But the documentation was being delivered late, and then we'd get rework, and the rework was late. Third problem was many of our user stories were getting done in the very last few days of the sprint. That was particularly problematic for our testers who had very little to do in the beginning and then usually had to work nights and weekends at the end of the sprint. So we had these 3 problems. So we said, okay, put on our Scrum Master hat, what can we do? Aha! We will run our Scrums by user story. So every day, we would go through every single user story. Maybe it sounds familiar. So this did help. We did coordinate a little bit better, but in the end, we still had all the same 3 problems. And now we had another problem. Really long Scrums. So at this point, we decided, okay, we need to take a deeper look and really do a root cause analysis and see what's going on here. So we put on our Kanban lens, and we saw that, the tier 3 requests, the help desk requests, were supposed to come into the release backlog, but that's not what was happening. Instead, we were getting an influx of items in the middle of every single sprint. So we know that wasn't supposed to happen, but it's really hard to say no to the customer, especially if they carry guns. So another problem, we noticed that the documentation requirements were not steady across every sprint. In fact, they were very bursty. There were certain times that certain documentation was due, and they didn't really fit exactly into sprint boundaries. So what's really going on? Well, putting on our Kanban lens, we realized that, in fact, instead of only having the first 2 work item types that we knew about, in fact, there was a lot more different types of work and different classes of service than we had realized. And this had always been there, but it was basically hidden. It was dark matter. And yet, it was taking a huge amount of bandwidth and energy for the team. So the Kanban lens allowed us to see that. So, at long last, our first incremental baby steps forward, we put together a physical board. So pretty typical Scrum board. You know, it's our step. It's an evolutionary step. So it's hard to see there, so I represented it here. It's a proto-Kanban board, pretty typical Scrum board. And you can see that we just have the business and infrastructure work item types there. So what's our next step, right? How do we very slowly, incrementally, with evolutionary change, how do we make things better? Well, the next thing we might do is add all of our work item types there so we can really see all the work that's going on. What's the next thing after that? Well, maybe we'll take that intermediate step, the in process, and widen it out a little bit so we can see sort of, are we almost done? Are we just getting started? These are very small, tiny steps that we can do that are not particularly controversial, but can help. So after that, we can really start to model our workflow. And one of the most important things we need to do is understand the expedited lane, and especially put a work in process limit there so we don't get so overburdened all the time. Then we can really start to understand our cycle time. And why do we need to know our cycle time? We need to know it because when the customer asks us, when can I get something, we need to have a better answer than just a guess. So, to recap, we started with Scrum. We're using the Kanban method. We're still not using the K word, but we're really excited to see how many more improvements we can make in the next 2 years. Thank you.